Process engineering focuses on the design, operation, control, and optimization of chemical, physical, and biological processes. Process engineering encompasses a vast range of industries, such as chemical, petrochemical, agriculture, mineral processing, advanced material, food, pharmaceutical, software development and biotechnological industries. Process engineering involves translating the needs of the customer into production facilities that convert raw materials into value-added components that are transported to the next stage of the supply chain, typically packaging engineering. But some larger volume processes such as petroleum refining tend to transfer the products into transportation that are then directed to distributors or bulk outlets. Prior to construction, the design work of process engineering begins with the block diagram showing raw materials and the transformations, unit operations desired. The design work then progresses to a process flow diagram where material flow paths, storage equipment, transformations, unit operations and flow rates are specified, as well as a list of all pipes and conveyors and their contents. Material properties such as density, viscosity, particle size distribution, flow rates, pressures, temperatures, and materials of construction for the piping and unit operations. The process flow diagram is then used to develop a process and instrumentation diagram which includes pipe and conveyor sizing information to address the desired flow rates. Process controls. The P&ID is then used as a basis of design for developing the System Operation Guide, or Functional Design Specification, which outlines the operation of the process. From the P&ID, a proposed layout of the process can be shown from an overhead view and a side view, and other engineering disciplines are involved such as civil engineers for site work, foundation design, concrete slab design work, structural steel to support the equipment, etc. All previous work is directed toward defining the scope of the project, then developing a cost estimate to get the design installed, and a schedule to communicate the timing needs for engineering, procurement, fabrication, installation, commissioning, startup, and ongoing production of the process. Depending on the needed accuracy of the cost estimate and schedule that is required, several iterations of designs are generally provided to customers or stakeholders who feedback their requirements, and the process engineer incorporates these additional instructions and wants into the overall design, and additional cost estimates and schedules are developed for funding approval. Following funding approval, the project is executed via project management. The application of systematic computer-based methods to process engineering is process systems engineering. Significant accomplishments. Several accomplishments have been made in process systems engineering. Process design, synthesis of energy recovery networks, synthesis of distillation systems, synthesis of reactor networks, hierarchical decomposition flowsheets, superstructure optimization, design multi-product batch plants, design of the production reactors for the production of plutonium, design of nuclear submarines, process control, model predictive control, controllability measures, robust control, nonlinear control, statistical process control, process monitoring, thermodynamics-based control, process operations, scheduling, process networks, multi-period planning and optimization, data reconciliation, real-time optimization, flexibility measures, fault diagnosis, supporting tools, sequential modular simulation, equation-based process simulation, AI, expert systems, large-scale nonlinear programming, optimization of differential algebraic equations, mixed integer nonlinear programming, global optimization. History of process systems engineering. Process systems engineering is a relatively young area in chemical engineering. The first time that this term was used was in a special volume of the AICHE Symposium series in 1961. However, it was not until 1982 when the first international symposium on this topic took place in Kyoto, Japan, that the term PSE started to become widely accepted. The first textbook in the area was Strategy of Process Engineering by Dale F. Rudd and Charles C. Watson, Wiley, 1968. The Computing and Systems Technology Division, Area 10 of AICHE, was founded in 1977 and currently has about 1,200 members. CAST has 4 sections: process design, process control, process operations, and applied mathematics. The first journal devoted to PSE was Computers and Chemical Engineering, which appeared in 1977. The Foundations of Computer-Aided Process Design Conference in 1980 in Henneke was one of the first meetings in a series on that topic in the PSE area. It is now accompanied by the successful series on control, operations, and the worldwide series entitled Process Systems Engineering. The Cash Corporation, which organizes these conferences, was initially launched by academics in 1970. Motivated by the introduction of process simulation in the chemical engineering curriculum. Roger W. H. Sargent from Imperial College was one of the pioneers in the area. PSE is an active area of research in many other countries, particularly in the United Kingdom, Germany, Japan, Korea, and China.